The problem I had testing this SimpleRTK system seemed very fragile to me, with all the wires running from here to there, and especially the antenna wire. So I decided to make a box and put in a battery system and a way to communicate remotely to the GPS for more testing. And by making a box, it becomes more portable, and we can put it in different areas around different terrain to see how that affects the GPS signal. The solution for me was to build a battery backup box that was waterproof and included the GPS, the Ardusimple board, which is number 5 here below. This box up at the top of this diagram shows the actual components that are inside of the plastic box I made to do the GPS testing. And it's got the Ardusimple board in here, which plugs into the Raspberry Pi with a single USB cable. Also, the backup battery plugs into the Raspberry Pi micro USB port with another USB cable. So all my wiring is simple plug and play, very easy to do. Camera plugs into the Raspberry Pi with a ribbon cable, and that's basically all of our connections, except I have another cable going from the backup battery out the side of the box so I can easily recharge it when needed. So it's a very simple box. The only thing not shown in this diagram is the antenna for the GPS that would be plugged in right here. Then they communicate to my LAN via Wi-Fi, and this Windows PC is running a piece of software called uCenter that communicates through the LAN to the New York State Department of Transportation CORS network, which is used to get the sub-centimeter accuracy out of these RTK GPSs without needing a second base station. So I pull that in over the internet. That gets mixed in with the TCP stream that talks to the Pi 3, which in turn funnels that data into the SimpleRTK2B board. So all I do is run uCenter. Instead of opening up a serial port to talk to the GPS, I open up a TCP port, which in effect runs through this network into the GPS even while it's out in the yard, because I have a dish to amplify my signal. The other software I run on my Windows 10 PC is a web browser to view the camera images that are streamed through a program in here. I'm going to go into that later at the last section of the video if you're interested in those details. Also, the description of this video is going to include all of these links to get these pieces of software. The RDP comes with Windows. It's a remote desktop protocol, so every version of Windows has that already in there, and that allows me to remote control the Pi inside the box in case I need to change anything. Okay, here's the new GPS box. This has your Ardusimple outdoor rated antenna on top, and I just glued a tin can lid on there to act as a base for the magnetic attacher there. And I've got some LED sockets and buttons I'm not using right now from another project I had in this box. Okay, so there, and the lid is the GPS, and in the base I have a battery from a cell phone, like a 10 amp battery, and that's just glued to the bottom. And then here's a Raspberry Pi Model 3 B Plus inside this case, which is on top of the battery. Got a lot of cable in here, And then there's a ribbon cable leading to a camera, which is just taped on the side now through a hole. And I've got that feeding to a streaming program on the Pi. And what the Raspberry Pi is also doing is taking the input and output from the serial over USB cable here that feeds into the SimpleRTK2B board, and just sending it over a Wi-Fi pipe. So I can go on my computer here and see, I'm not getting a very good signal because I brought it back down into my basement from outside where I was getting a great fix. And but when I open the port using the uCenter software, I simply go up to receiver, connection, and then give it a network connection instead of a serial port, and that allows it to open up my Raspberry Pi TCP streaming stream that's running over Wi-Fi, which is what I want to do, because I also want to run a camera on my rover that I'm going to be building, and the Pi has enough bandwidth to get the camera signal in. And you can see there's the camera is a streaming at 1280 by 720 right now. It's capable of doing a lot more, but that is all I'm running at the moment. So we get our camera streaming, we get our GPS signals, and I can also go into the Pi using remote desktop in Windows to change programs or just debug things. And this is the Pi desktop. So I can open up a terminal window in here, and then you can maximize that and have all sorts of fun with your Raspberry Pi as it drives around in your yard. Okay, even with the coating of snow, the box here is getting a fix. So in less than ideal situation here, less than ideal conditions, we're getting a solid fix. So I'm very happy with the response so far. Okay, I just showed you where I have the unit, and this is where the truck is, minus a little bit of slop from the Google Maps, which is not dead on. They're typically off less than a meter, but up here it's more because we're on a hill. Now this is the deviation map produced by the uCenter software from uBlocks, and you can see that's half a meter. This is 1 meter. So I'm getting a nice tight cluster around there, probably a couple inches, but this is while we're covered with snow on top of our antenna, so that's not a bad result. Now let's take a look at these two charts here, and if you looked at my previous video, we were getting a float fix, which I've since found out is kind of worthless. That means you're real close to getting a true fix, but it's hard to get a real fix indoors where I was doing it before. I put the device into the box, moved it outside, and now I typically get a fix in well under 10 seconds, which is really good performance. Now this chart above here shows all the satellites that we're using. The green ones are ones we're using. The red and blue are ones that are we found but we aren't using. If it begins with the letter G, it's an American GPS, as you can see from the flag right here. If it begins with an E, it's from the EU, with their EU flag there. R is for Russian GLONASS system, there's their flag. And then the B's, let's see if I can find a B on here today. There you can see these B's that are not in range right now. But these are Chinese satellites. So we're using 4 different constellations and 2 different frequencies, L1 and L2, with this GPS to get just really industry-leading results. And I think this ZFP9 is the, or F9P is the best deal out there in a GPS right now, as far as chipsets go. So our next step is going to be to put this into a moving vehicle, and I'll have an upcoming video showing that soon. I also have a camera in the box, and I have that streaming to a web accessible source, and I'll show you how to do these things too if you want. This is a Raspberry Pi camera, and you can see it's sitting on the top of the pickup there, and we're accumulating quite a bit of snow here today. Then I went to raspberrypi.org, as you can see here, downloads, and I loaded this thing called Noobs, which makes it much easier than it used to be to install the Raspbian software. And I just installed the standard latest Raspbian to keep things simple. So you need to put the operating system on your board, and after you've done that, then I decided to use it to get my GPS data to and from my PC. So it's basically I needed a bi-directional pipe, and I found this Stack Exchange question where somebody wanted to do basically what I wanted to do. So I'm also going to include this link in the description below, so don't worry about saving this. But the guy said, I want to use my Raspberry Pi as a serial to TCP converter, which is basically what I wanted to do, because the GPS, if you plug it into the Ardusimple board, comes as serial over USB. And somebody answered the question here, and he said use this tool called SOCAT, and just put it in a loop, because occasionally it's going to exit when you close your device. So I took this line here, and then I found I didn't have a TTY USB. Instead, I was using the GPS port, the U-Blocks port, on the Ardusimple SimpleRTK2B, so it comes up as ACM0 instead of USB 0, which is just a different driver. It's a more abstract version of the driver. Now, if you plug into the second USB port, you will see a TTY USB 0, which I did accidentally once. And that goes to their XB socket communicator, which I don't have populated on my board, so it did nothing. So you want to change this USB 0 to ACM 0, and then you should be good to go. The next thing I did is I put a camera onto the Pi, just the standard Pi ribbon cable camera, which I've had sitting around here for years for a different Pi, and that hooks up via a ribbon cable to the Pi. And I wanted to see that on a web browser for now, so I found this link here under randomnerdtutorials.com, and he basically gets the camera streaming, tells you how to turn it on here, enable it in the operating system, and you can follow all this stuff at your own rate. Then you need to find out what your IP address is, or if you're into networking, you can tie your MAC address to an IP that'll be consistent all the time. And then finally, you plug your ribbon cable in, and do this carefully and make sure you point it the right direction. So if you put this in backwards, it's not going to work. And you got to be somewhat gentle with these connectors here. Then make sure your camera works just by running a program called RaspiVid. Once that's working, I just took this program here, which the random nerd tutorial site got from another site, and I used this right out of the can and had no problems, except it was very low resolution, 640 by 480, and if you scroll down here, I didn't analyze this whole program, I just said, oops, 640 by 480. I changed that to a 1280 by 720 to get a little bit bigger picture, because the camera has 5 megapixels resolution, so that shouldn't be a problem. I did that and it worked fine. And then I inverted the image because the way I mounted it in my box was upside down. And I'll not bother talking about that because most people won't need to do that. Then I wanted all this stuff to start up automatically. And first I wanted the ability to get to this Raspberry Pi even when it's out in the yard without having to plug it into the HDMI monitor with a keyboard and a mouse as I initially did to set it up. So I found this XRDP software, which makes it look, the RDP stands for Remote Desktop, which is a Microsoft Windows protocol for remotely controlling your servers. So I use this to control web servers, RDP anyway, so I already had it on my notebook, and I turned the Pi into a server, and it's a one-line command to do this. Easiest thing you can do. Sudo apt-get install XRDP. You need to be in a terminal window before you do this, and if you don't know how to do that, that's all explained at the raspberrypi.org website. So this is very easy to do, and I was shocked at how well it worked after I did one thing, and that one thing is I removed the background from the desktop of the Pi. And before I did that, it was very slow. Before I did that, it was very slow at bringing the Pi up. Now see, I have a gray background. This was like a picture of a wheat field or something, the standard one, and it would slowly crawl across here. So once I got rid of that, things started working much better and faster. So right now I'm going over a Wi-Fi network to the orange plastic box where the Pi is there, and I can do anything you want to do in Linux over here. Now I want to show you it took me more time to get this software to start automatically than it did to get it all running. So if you're familiar with MS-DOS, there's a thing called autoexec.bat, which used to start things up when you started your system. It's probably still there now under Windows. But under the etc directory, right off the root of your Raspberry Pi, you will find a file called rc.local. And all I did is I opened this file. I did a sudo nano of this file from the command line from the terminal window to edit it, and I added one line, and that line is sudo sh and then this file here I call pipeline 3 because it was my third try at getting this thing to work. I'll show you that file in a second, but all this does is whenever you turn on your computer, it runs this, what they call shell file, but it's basically just a list of commands to start programs or run built-in programs. So let's close this, and we're going to go over to my home Pi, which is your default startup directory. Then I created this directory called bin under it, and if you look in the startup file, pipeline.sh, oh, I must have it open somewhere else. It's not letting me open it. pipeline3.sh. If I open this file, you can see it just has that 3-line while loop to get our bidirectional pipe going between the Pi USB port that points to the Ardusimple board, which is this device, and we're going to send it over the internet on whatever IP our system is to port 54321, which is just, you can put any non web serving port in there and probably use any number you want. So this keeps the link going at all times when you're running a piece of software to do two things. One, send the correction data from whatever device you're on to the GPS, which I get from the New York State Department of Transportation and their CORS network, and then in the other direction it brings back the data out of the GPS so we can plot our lat long in our whatever software we're using. And I gave a demonstration earlier using it with uBlox's free uCenter software. Now before this all happens, I first start up my camera so I can see what's going on there, and when I originally put this in this file, it would never get past this line because it was just forever running the software of taking pictures with the camera and streaming out to a web server. Well, when you add this little ampersand on the end, that means just kind of spawn that job off, I believe. I'm not a Linux expert, and let me go to the next line. So this runs immediately after it starts the program up. Now let's take another quick look at the program. This is the program I was showing you earlier that came from the Random Nerd site. And here you can see, first I changed my resolution and it didn't work because it was I hadn't changed it up here too. So you have to change it in two places, unlike what I said earlier. One, this is an image on the web page. This was 640/480. I just upped it to 1280 by 720 to get a little bit bigger of an image. And the other thing I did is down here I changed this to 1280 by 720, and this is what actually resizes the image. The other code was for putting the image onto a web page. This rotation, camera rotation, I uncommented this line which had a pound sign in it earlier, which means don't do the line, but I uncommented this and set it to 180 degrees so that I flipped my camera upside down and I was no longer seeing the pictures upside down. So that's basically that. Not a big deal. And you don't have to be a Python programmer because I'm not one, but just looking through the code you can figure out monkey see, monkey do, and make it work. So it is working. So it took me a while. I tried several different ways to do automatic startup unsuccessfully. This is the I finally got this to work. It took me like a day or two to work all this out, so hopefully that saves you some time. One other thing, when you're not running the endpoint softwares for the GPS, so the GPS is not in use, I found I could just take a terminal program. Like here I'm going to use CuteCom, and I can just open that ACM0 port, and boom, I'm seeing all the U-Blocks data here, or the NMEA sequences coming right out of the GPS. So that's a quick way to verify that your GPS is properly wired to your Pi before you go through the other steps. And there didn't seem to be a real old-fashioned terminal program on there, so I found this CuteCom software, which is I believe open source software available for download to put on your Pi. And you can just pick your device and open it up. So this is kind of a nice debugging tool. And you can just close out your session by clicking there. So that's how I got my box working. As a next step, I'm going to hook this thing up to a actual robotic rover platform, and that should be in our next video. Thanks for your time.